right, I'm back. It's been a crazy week. So, Cowboys play tonight, Monday Night Football. Make sure you watch it. Rangers won last night, of course, undefeated in the playoffs, beating those Astros. Game 2 is today during school at 3:37 p.m. That's kind of crazy. If you borrowed a calculator from me, please return it. 2 have gone missing in the last 3 days of school. Not cool. Please bring them back. I don't mind that you use it. I do mind if you don't tell me, but I know I wasn't here for you to tell me, so please just return them. That would be great. Okay? Please return my calculators. Okay, quick warm-up. So your name's on it. You grabbed it on the way in. We're going to draw this really quick, and we're going to do these notes as quick as we can, so please draw this real quick. Triangle with 3 acute angles. Okay, it's kind of like your normal-looking triangle. All the angles should look less than 90. Triangle with a right angle, so go ahead and draw yourself something that looks like this with a right angle. Now notice how ugly mine looks, so you can do it freehand, that's fine. In the future, maybe I'll give you a ruler, but there's a right angle. And then last but not least, a triangle with 1 obtuse angle. So go ahead and draw yourself an obtuse angle. See how this angle is obtuse, and then just connect it. And that big wide angle is a 1 obtuse angle, okay? Write this down really quick because we're about to do the notes. I'm going to pass them out if I haven't already, okay? Something that you want to make sure you've done. Did you turn in the construction packet from last week? You had 4 days to do constructions on that packet using the video notes and turn it in. So if you still need to do that, the supplies are in the back of the room. Make sure you turn that in. That is the first assignment on the second 9 weeks. So it is a grade, it is a grade, it is a grade. Make sure you turn in the constructions packet, okay? Today during class, I'm going to be working with some people to get y'all where you need to be because I know I haven't been here, but today's the last day to turn in work for the first 9 weeks. It is what it is. Y'all had all 9 weeks to get passing, so things happen, but we got to move on to the second 9 weeks. So here we are. We are about to do these notes. Here we go. Classifying angles notes. Write this down on your classifying angles notes. Let's zoom in here. Okay, so if you have 3 acute angles, that is called an acute triangle. We're going to write acute, put a little triangle symbol. If you have 1 obtuse angle, that's called an obtuse triangle. Kind of makes sense. One right angle, as you could guess, is a right triangle. My pen is acting up. And if you have 3 congruent angles, it's called equiangular. Equiangular triangle. Write that down. The one thing you want to notice is that obtuse just takes 1 to make it obtuse because you can't have more than 1. Right triangle takes 1 right angle to make it a right triangle. You can't have more than 1. But if all 3 are acute, it's acute. If all 3 are equal, it's equiangular. Okay. Now we're going to classify these over here. So look at CDE. From C to D to E. So if I follow that C to D to E, do you see how that triangle has a right angle? That is a right triangle. Cool. BCE. If I follow B to C to E, okay. Now, when I'm looking at BCE, do you see how BCE, that literally BCE angle, that's a big wide angle. That is bigger than 90, right? So since I see that 1 obtuse angle, that is an obtuse triangle. Okay, ABE, from A to B to E, if I follow this trajectory. Now, if I follow ABE, do you notice how all 3 of these have arcs? They're all matching, all the same. So that's equiangular triangle. Cool. B to E, from B to D to E. Now look, This angle E, that's greater than 90. That's an obtuse triangle. Cool. And then last but not least is CFE, C to F to E. Every one of those angles looks less than 90. So that is an acute triangle. Make sure you got that down. I'll give you 10 seconds. Again, we're classifying using these words at the top here. And now so that was all classifying by angles. So if they're asking you only about the angles, these are your options. Now, down here, what about the sides? Cool. So if you have 3 congruent sides, that is called equilateral triangle. If you have only 2 congruent sides, go ahead and draw this picture real quick. Just like you have 2 eyes, we call this isosceles. So I, like the letter I, isosceles. I know y'all love my drawing. It's so beautiful. So again, if I have 2 eyes and I have 2 congruent sides, that's isosceles. Okay. Now, if no sides are congruent, usually you see like 1 tick mark, 2 tick marks, 3 tick marks. They don't match. That's called scalene. Scalene triangle. Cool. Okay, let's take a look at these examples here. JKM, from J to K to M. Okay, so from J to K is 1 tick mark. K to M is different. M to J, oh, that one's different. Okay, so those are all different sides. That's scalene. None of them are matching. Cool. My pen is giving me trouble here. Scalene. What about KLN? K to L, L to N. Now, do you see how on KLN, KL has 2 tick marks, LN has 2 tick marks, but KN only has 1. So the only 2 of them are matching. When I think of 2, I think of eyes, I think of isosceles. And then last but not least, JKN, from J to K, K to N. Every one of these sides has 1 tick mark, which means they're all matching. And if they're all matching, if they're all equal like this, that's called equilateral triangle. Okay, make sure you've got that down. Give you 5 seconds, and we are moving on to 9 through 14. So we can classify. Here we go. All right, angles and sides. We have to do both of the notes, like the top part by angles and the middle part by sides. So let's start with the angles. Looking at number 9, do you see we have a right angle? Okay, so I would call this a right triangle. If I draw, all right, here we go. Right, comma, and then what about the sides? Well, I have 2 sides that are congruent. What do you call it when there's 2 sides congruent? Isosceles. My pen. Very good. Number 10, let's look at the angles. Number 10, I have, see this one angle of 114? That is very big, bigger than 90. What do you call that? Obtuse. Bigger. And then what about the sides? Okay. Now looking at those sides, they don't tell us any numbers, but I can tell you, put 1 tick, 2 tick, 3 tick, they're all different. What do you call it when they're all different? Scalene. Okay, unless you know that they're the same. Okay, scale. All right, number 11. All the angles are 60, 60, 60, 60. That's all the same. That's equiangular. Comma. And all the sides are 7, 7, 7. That's equilateral. I'll give you a little pro tip. All equiangular are going to be equilateral. Same thing. Okay. Number 12. What about these angles? All these angles look less than 90. That's acute. All these sides, they don't match. So that's scalene. Okay, 13. Angles, I got a right angle, so let's right. The sides aren't labeled. You can tell that they're all different lengths, so that's scalene again. And then 14, 97 is a little bit bigger than 90. That's obtuse. And then I got 5 and 5. That's 2 equal sides. 2 like my eyes, isosceles. Make sure you have this written down. I'll give you like a couple seconds, and then we gotta flip it over to the back. Classify triangles in the coordinate plane. All right, let's do it. Now, somewhere near the top, we need to remember how to do these types of problems. Okay, so we are going to write out the distance formula. Okay, so maybe at the top of your paper, go ahead and put d equals square root x2 minus x1 squared plus y2 minus y1 squared. Make sure you write that down. Write this down right here. Now, what you got to do on these is you got to use the distance formula to find all 3 sides. Okay, so I know this can be kind of obnoxious a little bit. We got to knock it out so we can do it on the assignment. Okay, so here we go. First, let's find JK, and that's no joke. I'm going to write out x2 minus x1, so negative 9 minus negative 7 squared plus y2 minus y1, 1 minus negative 7 squared. Okay, go to my calculator. So square root negative 9 minus negative 7 parentheses squared plus 1 minus negative 7 squared. Hit enter. I get 8.24. Okay, so that was JK. Now I'm going to take 2 other points. I'm going to do KL. So again, x2 minus x1, negative 1 minus negative 9 squared plus negative 1 minus 1 squared. Square root, parentheses, negative 1 minus negative 9, parentheses squared, plus negative 1 minus 1, parentheses squared. Look, I got 8.24 again. It's crazy. All right, and then so I did from J to K, I did from K to L, and now I'm going to do from L back to J. So x2 minus x1 is negative 1 minus negative 7 squared plus negative 1 minus negative 7 squared again. Negative 1 minus negative 7 squared, negative 1 minus negative 7 squared. Hit enter and I get 8.48. Okay. So that's 8.48. Now, yeah. By the way, my rounding was off. 8.246. This 6 means this 4 should round to a 5. Whoops. And then when you round 8.485, that should be 8.49. If you're that tiny of a bit off, I can be understanding of that. But we want to classify only by the sides. So we don't know the angles. We don't need to know the angles. When it comes to sides, either none of them are equal, and that's scalene. So look at these. Are all these numbers different? No, so it's not scalene. Scalene means they would all be different. Well, how many are the same? These two are the exact same, right? But they are not exactly the same as 8.49. So what do you call it when only two are the same? Isosceles, okay? My pen is not working. Isosceles. Cool. Now, you got to be able to do that on your own. Remember, if all the numbers are different, scalene. If two numbers are the same, scalene. Sorry, isosceles. And if all three are the same, equilateral. Okay. It's really hard to get an equilateral triangle on the coordinate plane, though. I'm not gonna lie. Okay. Well, here we go. Down here, solving for sides with algebra. Now, it says ABC is equilateral, so that means this equals this equals this. Okay. I want to solve for both x and y. Let's do that. If I know these are all the same, then this equals this, right? So I can say, hey, 49 has to equal 3x plus 1. So could you solve that? X on the right. Let's get rid of that loner 1, so minus 1 on both sides. So 48 equals 3x. And divide by 3. 48 divided by 3 is 16. So that's good. And then to get y, well, I know that for y, since they're all equal, then 18y minus 41 equals 49. And then solve that. So let's get rid of the loner on the side with y. We can get rid of that minus 41 by adding 41 to both sides. 18y equals 49 plus 41 is 90. And then if we get rid of that coefficient, we divide by 18. 90 divided by 18 is 5. Cool. Now, 17. It says DEF is isosceles, where DE is congruent to EF. So put a tick mark at DE and then a tick mark at EF. So only those are congruent. So if I know those two are congruent, I'm going to set those equal to each other. 8x minus 13 equals 5x plus 17. Now, can you solve it when x is on both sides? Remember, x cannot be on both sides, so you get rid of the smaller x. So minus 5x, minus 5x, 3x minus 13, oh my goodness, equals 17. Get rid of that minus 13 by adding 13 to both sides. 3x equals 17 plus 13 is 30. Divide by 3, and x is going to equal 30 divided by 3 is 10. Okay? Again, I did that a little faster because we've been solving these all first 9 weeks. You should be able to do that by now. If not, let's get it. Okay? Now, if x is 10, all you got to do is plug in 10. You got to plug in 10 where you see x. So I'm going to plug in 10 right here. So 8x minus 13 is now going to be 8 times 10. 8 times 10 minus 13. 80 minus 13 is 67. So I know DE is 67. And since DE and EF are the same, EF is also going to be 67, right? Like they have to match, right? 67, 67. And then I'm going to plug in X down here for DF right there. Cool. So X plus 21 is going to be 10 plus 21, which is 31. DF equals 31. All right. Cool. Now, sometimes you don't have a picture, but you could draw a picture, a really ugly picture like mine, PQR. And it says PQ is 18x plus 1. QR is 24x minus 17. If I can draw. PR is 15x plus 10. Find x and the measure of each side. Well, equilateral means they're all the same, right? So all you got to do is take two of them, set them equal. So 18x plus 1 equals 24x minus 17. Again, when they're equilateral, you can just set them equal and solve, okay? Again, x is on both sides. You got to get rid of the smaller x, so which is 18, minus 18x, minus 18x. My pen is not working. 1 equals 24 minus 18 is 6. Bring down minus 17. And then x is on the right side, so we need to get rid of the loner. How do we get rid of that minus 17? We add 17 to both sides. So I get 18 equals 6x. And then to get rid of that coefficient, 6, we divide by 6. And we get 18 over 6 is 3. Okay. So once we have x, we can plug it back in where we see x, like right there. So for PQ, right, it equals 18x plus 1. I'm going to replace x with 3. So 18 times 3 plus 1. I should get 54 plus 1, which is 55. PQ equals 55. Now, it's equilateral, so if PQ is 55, QR is 55, and PR is 55. They're all 55. Cool. All right, on this last one, you try. Okay, I want you to try this one. Try it on your own. Use what we've learned so far, and then I'm going to pass out the assignment so that way you can work on that. Tomorrow's PSAT testing. I'm sorry. Tomorrow's PSAT testing. We won't be working on this tomorrow, but we will have time in class on Wednesday to do the assignment. All right. So you try 19 and then get started on the assignment. All the assignments are due today for first 9 weeks. All right. So Cowboys go Rangers.